Assalamualaikum and hi to my examiner panels. I am Nafifi Nadira. I would like to present about the effect of white towards electric field in high voltage cable. For background of study, high voltage transmission and distribution technology has advanced to assure efficiency and benefit both producers and consumers. High voltage direct current or HVDC is preferred for long distance underground transmission due to its minimal losses for high voltage transmission. There are numerous elements that influence transmission performance, including high voltage cable performance. Second, high voltage cable influenced by a variety of internal and external factors, including insulator performance. As we know, a good characteristic of cable must be considered to ensure there are no breakdowns occur during power transmission and distribution process. One of the major problems that can shorten life of cable is the presence of void of water and air. Due to void, bubble or defect, partial discharge is caused that can be resulted in reduced life of the cables. Fourth, void can be formed in power cables insulation like paper oil insulation, XLPE, which is cross-linked polyethylene. EPR, paper cable relatively resistant to partial discharge activity, but XLPE cables are not. Fifth, effect of void towards high voltage cable will be analyzed using COMSOL software. For the problem statement, cable insulation must withstand constant electrical, thermal, and mechanical stress. If tension exceeds the limit, the cable must be damaged. Cables are commonly utilized in underground application because of its advantage over other material. XLPE is rapidly being utilized as an insulating material in the present circumstance. Other factors that can affect shorten life of cable is partial discharge, impurity, roughness, cavities, and space charge. The electrical stress is greatest at the cross surface and at the sheet inner radius. As a result, there will be a substantial difference between maximum and the lowest stress in insulation. Then, one of the primary issues is the presence of water, voids, or cavities inside cables insulating layer. The presence of pollutant also increases stress, which can lead to insulation failure. For objective and scope, there are three objectives. First, to determine the effect of void at contaminated XLPE insulator cable. Second, to evaluate the effect of location of void towards the distribution of electric field in the cable. Third, to obtain the electric field characteristic inside various void in the cable. For the scope, develop 275 kV XLPE cable with aluminum sheet. Second, COMSOL software has been used for analyze electric field stress in the cable. Last but not least, for scope, void effect characteristic being determined towards electric field through high voltage cable. For the literature review, there are some related previous work, such as the effect of voids has been analyzed. This is location of void center from conductor. In this scenario, the distance between the conductor surface and the void center is used to determine the direction of the void. The graph shows the maximum void stress as the distance between the void and the conductor surface change. It can observe that maximum void stress decreases as the distance between the void center and the conductor surface increase. Void stress increase when get closer to conductor surface, and as the void gets further away from the conductor surface, the maximum void stress will decrease. As a result, the void closer to the conductor surface is hazardous to the cable insulation breakdown. So, for the size of void, the insulation material used cross-linked polyethylene, which is SLPE, with a relative permittivity of 2.5 is considered. In that situation, the maximum void stress is 3.25 MV per meter when the void size is 0.6 cm. The result shows that as the diameter of the void rises, the maximum void stress increases, while the material breakdown strength will decrease. It also indicates if insulation thickness is reduced, void stress increases and vice versa. For the next study is using console software, which is for the first picture is about electric potential in 3-core cable with time, and the next is electric distribution in 3-core cable with time. It shows that the conductor has the same potential as the ground as shown in that graph. The potential value falls as the distance from the conductor rises. The potential distribution along the void is not uniform and it should decrease linearly from conductor to sheet. For electric field in power cable without void can be seen in that picture. The electric field distribution, because of the strong electric field, mechanical stress will occur, resulting in gaps in the insulation. When the voltage stress is rise, the valence electron in the electric material atoms are eliminated. As a result, the insulation lost its characteristic and became a conductor at the point of failure. Partial discharge is such fractures may cause electrical breakdown. And the next picture for it is air field void in cable insulation. The electric field in the 3-core cable is buried in the soil with water gaps may be seen in that picture. Water trees may grow in low electric field and take a long time to form. Then, I will present about the methodology. This is about project analysis flowchart, which is first start. Then, we have to select title selection and configuration. Then, variable selection. Then for the next step is evaluation and verification. If yes, it will proceed to configuration stage, which is pre-assumption and specification determination. If no, it will return back to title selection. After configuration stage, it will lead to modeling stage, which is design prototype and condition setup. Then it will proceed to simulation stage, which is solving and analyzing. Then, if analysis result is success, it will go to the end, and if no, it will return back to the simulation stage. For the next picture is the step for design cable in using console software, which is first start, then we have to declare environment setup, then we have to design geometry, then it can proceed with material properties specification, which is we have to label the layer of the cable, then we have to define boundaries, then after define boundaries we have to simulate, then we can mesh and get the result and end. For preliminary result and analysis, for first picture is about clean design for 275 kV power cable, which is the inner of the design is conductor and it consists of copper. The next layer of SLPE insulator is followed by aluminium, and final year for this design is HDPE, which is high density polyethylene. For the next picture is about boundary layer for high voltage cable, which is for the first circle is terminal voltage, which is 275 kilovolt, and the outer diameter or outer sheet is ground terminal, which is that lead for 0 volt. This is electrical potential distribution with white and without white. From that figure, we can conclude that the electric potential that near the copper is larger. The maximum electric potential without white is about in range 250 kilovolt per meter, and with white it's about 275 kilovolt per meter. It can be seen in the picture with white. We can see that electrical potential is higher around the copper because of the presence of the white. This is a graph of electrical potential distribution without white. These characteristics are being analyzed to identify the point of electrical potential distribution. Firstly, for the cable without white, it shows that the electrical potential suddenly increase before become stable at certain point and finally decrease until it goes to 0. The higher part in the graph shows electric potential around HDPE layer, which is in range 40 until 60, in range between that. This is for the graph with white. We can see that there are a little bit change in between 80 to 100, which is the graph if not smooth. With the presence of the white defect, the graph of electrical potential distribution shows that made a little bit change. Then it about electric field distribution without white and with white. As expected, the higher value of electric field is on conductor. The electric field distribution around the left hand face or upper face are in the same average around each conductor, which is expected due to the symmetry of the cable. We can see that the cable that containing white defect, the electrical field is higher at the surrounding. On the other hand, indicating that the existence of white would cause the surrounding electric field distribution. The result also shown the distortion cause of white defect. This is graph of electric field distribution without white. As mentioned, the size and location of white also plays important role in the field distribution of a cable. Firstly, for the cable without white, it shows that the electric field is increasing until it dramatically increases at aluminium part before become stable. The graph also continuously increases until maximum electric field achieved. So, this is for the graph that containing white defect. When the white is present in the insulation, The electric field of void is increased as shown in that figure. Electric field at the void is higher due to the lower permittivity than the insulation material, and so that the insulation material has to withstand more stress at the location of the void. Breakdown strength of void is air is lower than the insulation material due to the lower permittivity of it. So, the breakdown strength of the insulation material is decreased due to the void inside it. So, for the conclusion, the characteristic of electric field include of having void and without void. According to the modeling result, the electric field inside the cable will be distorted when compared to the usual operating state, and the insulation between conductor will probably break down. Second, accurate estimation of electric field distribution inside both perfect and a flawed cable was achieved using a very dense mesh of more than a boundary element. In the case of a defected cable, the electric field strength is significantly increased inside the void defect. The variation of the electric field value inside a typical high voltage cable agrees very well with theoretical results obtained using simplifying assumption. There are some recommendations and future works. The recommendation is the outline are based on the finding and potential outcome for each parameter used. As observed with this void, the electrical field will fall, allowing for future study in their usage as filler dopes in high voltage wire. Furthermore, a recommendation may be made by investigating space charge density in the context of contamination void in high voltage cable. Parameter also used for this project is limited. Thus, other parameters can be investigated. This will lead to improved characteristics for these pollutants, reaction to cable performance. So, that's all from me. Thank you.